With the availability of open source electronics platforms and the growth of 3D printing in the country, the hub has since taken the challenge to help create solutions to help flatten the coronavirus curve. We chat to robotics developer at Resolution Circle, Spies, about this innovation. Carl, welcome to the program.
Good morning. Thanks for having me here.
So, Carl, how does the current crisis allow opportunity to harness the passion for hobbyists and makers in South Africa?
I think what we found really exciting is that most of the materials needed for these projects to help detect and prevent COVID-related elements are quite accessible. They're quite easy to get your hands on. What we've really been excited about is the hobbyist and maker community coming together and saying, look, we want to jump in, we want to help with this. What we love, however, is with our association with University of Johannesburg, we are able to bring that professional engineering experience to it. It's not as simple as pulling plans off the internet and then printing something. There are quite a few considerations to take into account.
So, Carl, tell us a bit more about the work that you do as the Resolution Circle. How will your program assist?
Yeah, so what we've been doing is we've got a consortium which is made up of quite a few bodies, some legal, some medical, technologists, etc. And what we're doing is we're basing our project on the MIT ventilator project. We've taken those plans and we're adapting them through our consortium for local conditions. So specifically Resolution Circle, what we'll be doing is we'll be taking 50 of our NDP graduates, actually helping them to assemble the ventilators, to test them, and to also support and maintain them. So in doing that, we've got another 50 cool South Africans that we've now developed as medical technologists to help them gain the experience. So that's specifically what we're doing, is helping them to assemble the ventilators, and then obviously once they're out of the hospitals to then maintain those, which is a big part of what we need to do.
So for those who are interested in taking part in this program, can anyone take part or enroll for the course, or do you have to have specific skills or abilities?
Look, obviously we prefer students that have some electrical or electronic engineering experience, but certainly Resolution, we're open to inviting people to help out with many things. We need to print masks, we need to print face shields, etc. So if you're interested, you can contact Resolution Circle. We are on the internet. Just give us a shout, and then we'll certainly be able to connect you or plug you into a project that's relevant where you can contribute your skills, and then maybe we can do a little bit of training as well and skill you up quickly.
So, Carl, let's zoom into the career in electronics and engineering. What does it offer, especially for young people?
Well, what we're excited about is, remember the President spoke about the whole, fourth industrial revolution, which is upon us. What we're excited about is we're able to take children from grade 7 upwards to start teaching them robotics. You may not get this on camera, but these are some of the few small devices we can play with. So from very young, we can start teaching kids, even with Lego again, so I shouldn't be waving my hands around, but even little simple devices like using Lego, we can start to teach children the basics of what we call mechatronics. A little bit of mechanical engineering, a little bit of electronics, and then some coding. So right from primary school level, you can jump into a career in electronics. You don't need to go to university and get a degree initially. We take many students from TVETs, and there are many, many paths to engineering in the country.
So the growth of 3D printing in the country has shown us that there is a strong community of enthusiastic makers out there. What can you tell us about this?
Well, we've been surprised. You could jump onto Facebook and look at the South African Maker Collective. A lot of people have 3D printers in their homes that were bought on a whim, or people got excited and they just sat there gathering dust. What we're allowing now is for people to connect, to say, I might have a 3D printer at home, or I have some experience I can help out, to start collecting a community of these people together and then help them print. So again, something fun to look at is jump onto Facebook and look at the South African Maker Collective. You'll see a lot of 3D printing work happening there.
And now looking at the battle to stop the spread of the coronavirus, how can people then use these skills to assist in creating solutions to help flatten the curve?
Well, it's not just the ventilator projects, which take quite a lot of skill, and they are quite involved projects. The exciting thing is in learning to design these little programs, or even learning to take blueprints off the internet and start manufacturing those devices, gives you an inkling or an idea into what's involved in engineering, what's involved in especially creating devices for medical situations, which needs certification, lives are at risk. So I think it's no matter where you get involved in this project to help with COVID, whether you're doing simple 3D printing or more advanced ventilator projects, it gives you an entry path into engineering, and then you can quickly assess yourself against the skill levels needed for these projects, and that's where you get into engineering. A nice practical way to learn engineering without vanity projects, making cute little blinky things that don't do much.
So, Carl, surely this also talks to how a community wants to come together to use their skills and resources to help solve problems. Tell us about this.
Yeah, absolutely. The Americans have sort of pointed at a three-letter plan, so Plan A, B, and C. Plan A would be for government to jump in and take over factories, right, and say we're going to produce ventilators and emergency equipment. Plan B, what the Americans call is corporates coming together and saying that we'll produce masks, we're going to jump in and we'll produce whatever equipment. Plan C is really where we fit in. Plan C are the hobbyists, the passionate people, the entry-level engineers who want to get involved. So Plan C, we've learnt, makes up quite a large portion of the COVID approach in terms of helping people with emergency supplies and equipment.
So in recent weeks, we've seen how the U.S. government has donated ventilators to South Africa. But do we know anything about work that's being done to have locally produced ventilators?
Yeah. Not yet. I was chatting on ENC on Sunday. I did hear that three companies have been appointed to start producing ventilators in the country. Apparently not one has been produced yet, so that's a concern we have. What we'll be looking at is, especially with donated ventilators, is training up our NDP graduates to at least maintain the equipment. Because, once it's in hospitals, it's going to need service and maintenance. Again, there will be a shortage of technicians to do that. So we'll certainly be able to help with the maintenance of those machines.
Speaking about the production of ventilators and other technologies, what are the legal and certification issues to consider?
Yeah. Well, that's why we developed a consortium. We saw a huge group of passionate hobbyists, and of course the legal implications. Remember, if you produce a simple ventilator and you let it loose in a hospital, if someone dies because of that ventilator, either too much oxygen, too little, or the equipment doesn't have a fail-safe, you become liable for that. So while a lot of people are passionate about this, they haven't thought through the implications of, wait a minute, I can actually be liable for this. So again, it's woken us up to the need for decent engineering skills, for professional practices, and then for connecting people to these projects so they can help wherever they are.
So one of the courses that the Resolution Circle teaches involves additive manufacturing. What can you tell us about this?
Yeah, so additive manufacturing run by Opan Kuna, one of our favorites. He'll take you right through designing. So you have the concept in your you have the concept in your head. So taking that concept, understanding materials, doing the basic design, and then actually 3D printing it, printing out a little prototype. So kind of in 3 days, we take you from having an idea in your head to printing actual little parts that you can use for your project.
Now, using a yeah, sorry, you can continue.
Sorry, I just wanted to add that while most people consider 3D printing in terms of plastic or layering polymers on top of each other, we are starting to use additive manufacturing, obviously, to print metals as well. So you can 3D print in metal too.
So using a platform such as Arduino during the time of lockdown, is this ideal to provide children with an exciting pathway into engineering?
Yeah. What we love about Arduino, very, very cheap. I mean, these little Arduino boards, which could drive a ventilator, which could drive a lot of things, like $200. So we're very, very excited about how easy these platforms are to get. Also the fact that they're open source, so you can take the schematics, you can design your own, you can replicate them. We love a community that's open and free because we can rapidly share insights, knowledge, blueprints, patterns, etc. with each other. Arduino is just brilliant for that.
Well, Carl, thank you very much for your time. That's Carl Spies, robotics developer at the Resolution Circle, talking to us about how technology is being used.